It's a very, very logical question if I talk about. So it happened, ChatGPT got launched and everyone was behind Gen AI. If you talk about companies like Google, Microsoft, AWS, Oracle, everyone is talking about Gen AI. But it may look like it happened overnight. I'll give you a very basic example, again, coming from my analogies kind of thing. Let's say a nation is planning for a nuclear test. Now, nuclear test is not something which you do overnight, right? There would be a lot of preparation required for it. There are a lot of things you need to consider. And when that test happens, then everyone knows in the world that, oh, this happened and this country is now a nuclear power. Same thing happened here. A lot of things were happening behind the scene which we were not paying attention to. And when it manifested into a form which everyone could interact to. Like if I'm talking about machine learning, I think those type of program existed even 50 years back when IBM created Deep Blue, a supercomputer who could play chess. That was one of the type of machine learning. But when it became a consumer thing, like where everyone could go open up a browser and start something, that is where Gen AI become very popular. But if I go into little more detail that how we have come to this particular point in so far, I would go ahead and say that there was a lot of amount of data which we were accumulating. If you look at today, internet is generating data at a rapid pace which was never imagined. And then cloud computing and AI chips were enhancing. You talk about companies like Nvidia who are coming with newer innovation where we can perform a lot of processing for graphical thing. A lot of compute power is available, and that became the machine learning innovation. So when you combine all these things, all the data which is available for training your model, all the type of hardware which you can use to perform this training much faster, and the third is algorithm which are being used or the smartness into the compute which we have created, that all combined together is what has created the generative AI. So it hasn't happened overnight. It may be visible overnight, but it was happening from long time. And I would say it is like a fruit was a tree you planted and now you're getting the fruits out of it.
True,
Does it make
true.
sense?
Of course, it makes sense. And I know that data is the new gold, right? So, what do you do
Yeah,
with so much data? So, I'm
exactly.
sure we can use that there. So, you used a lot of terms, right? And there is
Mhm.
a whole lot of terminologies that go along with AI/ML. So, I would require a little clarity about the fundamentals. So, can you help me with that?
Yeah, fundamentals are very important. I always say that if you want to build a big building, you or a tall building, you need the right foundation. And let's try to cover some of the fundamentals here. Some of you may already know it, so just bear with me till we reach to the point where we can use it for a very specific thing. But we will talk about very basic things. Sometimes we get so bogged down by confusing term. So let's talk about generative artificial intelligence. AI stands for artificial intelligence. And what is intelligence, right? We do not pay attention to it, but everyone is having some type of intelligence. Whether you talk about is it a human being or is it animals, they will all have some way of comprehending things, understanding, and then benefiting from that expectation, right? So that is what we call intelligence into dictionary definition. And most living beings have intelligence. Whether you talk about humans, obviously we have it, animals also have it. We can obviously find a lot of information on internet about the different type of animals who have different type of intelligence. So intelligence is something which allows you to understand what is happening and maybe take a action based on it or use that knowledge to do something about it. So that is intelligence, which we take for granted being a human or being animal. But now when we talk about making a machine aware about that intelligence, that is very complicated. So I could identify that I am wearing a blue shirt, others can identify a blue shirt, but for machine it would be very complicated. We have to make them understand what is blue first and how they can relate different patterns of blue. So that's what would be very important for machine learning. So I give you a theoretical definition first. So the theory and development of computer systems which are able to perform tasks which require human intelligence, right? If I have to identify someone's voice, I have to identify someone's photo, I have to identify a particular color, that would require some intelligence on that. So could be speech recognition, could be decision making, could be understanding language or translating between languages. That is all going to be part of your artificial intelligence. Common
So,
example, we are
Ashish,
using it. Yeah, go ahead.
I have a question. Like, if it is mimicking humans, so why do we need artificial intelligence? Can't human intelligence achieve the same task? We are already been doing it for so long. So why suddenly we need that?
Good question. We still have a limit of how much manpower we can devote to a task. Let's say I give you a task that, hey, you have to go and read all the work of William Wordsworth, or you have to read everything which is written by Edgar Allan Poe. You may have a limit of how much you can retain and how much you can process. Maybe if I have to achieve the same task, I could give the task to 100 people combined. But then assimilating that knowledge, combining it, it would be very difficult. So we want to ensure that we can be more creative And the common things, let's say ordering a shoe for me, or my fridge is not having the enough cola, my fridge can be smart enough to understand it and then order it for me. So anything which we can help to save our time instead of doing time consuming tasks which are repetitive, which can be offloaded, why don't we do it? Very simple example. Most of us may in India have a advantage of having a domestic help, right? Why we have a domestic help?
Right.
Can't we do those things on our own? We can, but maybe we have more priorities. Maybe you have to take care of kids. Maybe you have to go to job. So we could basically paying somebody to help us into doing things for us. Same thing here. If I have to write a quote, why I have to read all the work and then get it done? Maybe I could have a marketing campaign run by AI. Maybe I have to create images which AI can help me rather than I go and shooting those images. So that's where we are trying to augment our own expertise by AI. Obviously, AI is not replacing humans because there is limitation of what AI can understand. But yeah, idea is we want to ensure that we can leverage our time into more productive thing rather than doing mundane thing which can be generated by machines. Does it make
Makes
sense?
sense. Yeah. So it makes us more productive, agile, and efficient. If
Exactly. And
that's what you're saying.
repetitive, right?
Yeah.
Means I could
Repetitive.
do the same thing, but I would get bored, right? But a machine won't
Right.
get bored, hopefully. So that's the thing we are trying to do.
So we must be using AI already, right? In our day-to-day life. Probably most of
Exactly.
us are ignorant about it. Can you give me some
Not
examples where?
ignorant means sometimes some things are so obvious that we do not pay attention to it. It's a very so
True.
obvious thing. Same example like maps and navigation. We all use Google Maps, right? We all use MS Word where we type something and if a spelling mistake is there or it can suggest me what the next word
Right.
would be. So in map, nobody has said that I will always feed all the data for point A to go to point B, then B to C. We have fed the information about the geography, maybe the landmarks, and then map is smart enough to calculate distance. Maybe if there is a disruption of traffic, maybe there is a flood, maybe there is a road closure, it can get data from other agencies and then give me the best route to go for. I could say, hey, I want to go only by car. I could say I want to go only by train. If that time a train is shut down or not operating, it will find another train for me and suggest me. Same thing is facial detection. Like you go to your airport security, probably your face would be recognized there. This is happening. Text editor. So you are having search engine. When you search in Google, one term is there and multiple terms comes out of it. That is all the things which are commonly happening, but we do not specifically call them AI. But yes, it is a shape or form of AI as it happens.
Makes sense. So this was AI. Now we generally club AI and ML together, machine learning. So are they related to the same thing? Are they different? What's the difference? Can you just clarify about that?
Makes sense. That's a good question because these two terms are used so interchangeably that hey, I am using AI, I am learning ML, I am doing this, I am doing that. So let me try to clarify a little bit on that. And I will give you some example also you can relate into real life too. So when I am talking about AI, we are trying to create a capability of a machine who could be similar to a human being, right? Could be similar, could be more faster, could be little slower, but what our brain is able to do, if we can get machines do these things for us, that is what we refer as artificial intelligence. So AI, we are trying to either mimic what a brain can do or go beyond what a brain can do. Like if you ask me that do a total of two digits which are $10 million and this number, I may not be able to do it very fast, but machine can do it. So either it will be equivalent to my human capabilities or it will be beyond capabilities in some year as we see. So that we refer as artificial intelligence. I would say you are able to discover things, find new information. Maybe you can infer, you can take well-informed guess about something, or you can perform reasoning, you can think and make judgment. That is what artificial intelligence. Making machine intelligent artificially, that is what we call AI. Now, how about ML? So ML is a part of artificial intelligence. How we can make machine intelligent? So we can then train machines for being intelligent. That is what we call machine learning. So artificial intelligence is basically machines simulating human intelligence and decision making, like predicting what would be the next turn I have to take or what would be the next location I should be going from my map. That is artificial intelligence. And then ML is ability of machine to learn without explicitly being programmed. That is the main difference here. We will not explicitly be saying to machine or let's say map application that calculate distance from London to Shanghai. Maybe it knows where the London is, where is Shanghai. It would be able to do a calculation on his own. And next time you say, I now need a distance from London to Amsterdam, it would leverage the same type of mechanism to get a calculation done for me. So it is a machine who are smart enough to learn things like we do rather than being programmed for everything. So AI is more on the programming side. ML is more on the learning side of thing, and learning, when I call it, is mostly about patterns, it is about anomaly detection. So we'll talk about it. Just to give an example, let's say machine that can play chess based on the rule. So you create a program, probably all of you have played chess onto an online platform. So what happens there? Machine has been programmed with all the possible moves for the chess, and that has been fed into the system, and system is responding back to that. But what if machine can learn to play the chess from analyzing the past chess game plays by the human, how a grandmaster is playing, if it can understand those moves, in what situation that move was taken, what type of situation was it, what type of challenges were there, and if then machine can decide based on all the data, process it, and then give me the result, that I would call a machine is now learning. Does it make
Ashish,
sense?
I have a question here. So we have been traditionally writing programs using procedural instructions, right? So when I have a business problem in my company, how do I understand whether ML will be used to solve it, or I should be doing plain simple traditional programming? Can you give me an example of a
Yeah.
problem where I should be picking one over the other?
Okay, let's talk about a situation. Let's say you are going from point A to point B. So, can you predict all the possible challenges you may face? If you can, you could write a program who could help you navigate all these things. But if I am not aware that what could be the challenges I am facing, then probably you should be making a machine learning program for that. Let's give an example. Now, you are creating, let's say, a decision tree or a program which would be able to differentiate a white color and a blue color. Done. Simple program. That is
Right.
good for artificial intelligence. But now I want a program who could differentiate all the possible color. It should be able to differentiate all the type of fabric which are being used, and it has to differentiate all the type of shapes I could wear into my into t-shirt or shirt or those type of things. So as you see, the probability of things and the logic which you need is becoming bigger and bigger. You cannot write program for every single thing, right? That
Right.
time probably you would be needing machine learning.
Makes sense. Right.
Can let me give you one more example on that. Let's say you are on a website like amazon.com. Now amazon.com may be displaying you your last bought product, right? That is coming based on who you are, and the rule is there which will be identifying, oh, this is Ashish, he has bought this thing,
Right.
and let me display it. But now it may generate recommendations for me, and that recommendation can be based on my taste, could be based on my location, could be based on weather, could be based on what I last purchased, could be based on how much I spend on Amazon. So as you see, n number of variables are there, and my programming logic may not be able to create a relation between all these n number of elements, and that's where machine learning would be much useful for me.
Makes sense. So that's more efficient, I guess, because you are not explicitly putting in the instructions, conditions, and rules, and your machine learning is algorithm, as we call it. I think that's learning from just the data that you're providing it, right? So it's
Exactly.
self-intelligent.
So yeah, self-intelligence. So it's understanding. It is understanding the context. It is understanding the environment, and then taking some action based on that.
Makes sense. Yeah. So I just have a question. So when I'm probably typing words in Google search, and I see there's, as soon as I type a word and I see this list of next words which are coming in, is that ML that I'm seeing there? Is it predicting the next word?
It
Is
is, in
that
a
an
way, yes.
example?
It is predicting on the next word what you, and that will be based on your search pattern, right? So maybe
Right.
Google knows that is it a person with age group 10 to 20 typing this thing, or it is a age group person 21 to 50 typing it, and it may have different word predicted for me. So yes, it is using ML behind the scene for it. It may not be a full-fledged form of ML. It is very specific, what we sometimes call a narrow ML, which is just focusing on a single task and letting me complete one
Hmm.
single task. But yeah, it can be trained to do different things also. So like you could predict the next word. Why don't you predict the weather? Why don't you predict the stock market? So you could enhance that model's capability as we move forward. So that is possible.
Makes sense. So I guess when we are shopping online on our Amazon app and it's recommending the associated purchases I can make, so that's again personalization. That's again machine
Exactly.
learning which is happening, right?
That's
Okay,
true.
makes sense. All right. Yeah. So, Ashish, so now I understood what machine learning is, but I would like to know, in the process of machine learning, we create something called as a model, right? And that model is that intelligent black box which is actually making predictions or making inferences, as we call. So, can you share a little insights about what is this model? Where does algorithm come in? So, that entire process I would like to know.
Yeah, let's why not? That is fundamental block. So everyone is talking about we have this model or we have this LLM models or we have foundation models. So let's try to demystify what is model, and then we'll go into deep of it. Obviously, we have time limitation, but we will try to talk about what is a model. Let me again translate thing to a business need, and everyone who is joining, a suggestion is A technology may be good, but a technology is not useful if it cannot solve a business problem. So whenever you are
True.
learning a technology, as a tip from me, understand what is the use case for this technology. Nobody just created machine learning because it could generate cat pictures or it could generate dog pictures, right? There was some business need, and that's why that particular product or service or software has been developed. So let's try to understand how we would be able to understand machine learning fundamentals. So let's take a business need into action. A company who is like Amazon, or you set up your own company and now you want to have product recommendation. Obviously you have a customer base. Now I want to know what my customer would be buying next, what I can be giving them, what I could be recommending them. So that is where we have to build a recommendation engine. And now we have two approaches. One, consider that a classical programming approach, which I was talking about, that you write rule for everything, or you have a machine learning approach where you make a machine aware about the circumstances, about the data, about the person who is asking the question, and then machine predicts based on that. So classical approach, and we'll talk about machine learning approach. If I'm into a classical approach, what I would be doing, I would be knowing that person's purchase history, and then I would be formatting that purchase history, augmenting with some of the rules, and that will generate a recommendation for me. Simple rule I could write would be like this. So if a customer has bought shoes and is in between age range of 18 to 45 and lives in cold climate, recommend warm socks. So that is the rule I have taken. Now this rule can only apply if that customer has bought shoes, if he or she is between 18 to 45, and if they live into a cold climate, right? So if a person in Dubai is buying a shoe, this rule does not apply to it. So if I want in Dubai, this rule should also apply, so I have to create another rule. Now let's say that we have created 10 type of rule, 100, 500 type of rules, but again there is a limitation how much we can process on it. So here rule N says if a customer has bought kids jacket and is between age of 25 to 55 and lives in warm climate, recommend a travel bag. So probably kids jacket he or she is buying, he is 25, 55, so probably they want to give it as a gift. Maybe because of that they would be traveling somewhere and it's a jacket, they live in warm climate, so probably it is not for them, it is for someone else. So they may travel, and let me recommend a travel bag to them. So what is happening here? I am trying to predict as much possible permutation and combination can happen, but I cannot predict every single possible option here. What if that person may not be interested in travel bag, or he has already bought a travel bag? Why I should again recommend a travel bag to him or her? So that's where we need to figure out a way where we can let machine learn and then predict based on what he has understood. So let's go ahead and talk about these things. So when we talk about machine learning approach, what we are doing here, we take the same purchase history, we collect data from site-wide sales we have made. Amazon has made billions of sales of product, and then obviously they are able to understand a pattern in that sales. So we feed that particular software, which we are calling as a model. I'll explain what a model is, but a model is basically having a purchase history as an input, site-wide customer sales data, what other people in that age range, from that location, from that geography, from that time zone has bought, and what he or she recently bought. Let me leverage all the data and provide a recommendation on it. So idea is, as much data I have and I can process it in a logical sequence, I would be able to create better recommendations for me, right? So that's what we are trying to achieve from machine learning. So what is happening here? Rather than me creating rule for everything, machine is smart enough to derive rules from the data itself. It adapts to complexity in customer profiles. There can be different type of profiles of customer, and then we have trained model ahead of time, so it will not require to process that rule that very moment. What may happen that you logged off today from Amazon, but it has calculated that what would be the recommendation product, and next time you log in and that product is displayed to you. So rather than explaining that information and giving it to the same time, we may have processed it and we may have created it afterwards, should not be a problem. So that's the machine learning approaches. So what I'm doing here, I'm combining all the available data from the site in which I can derive a pattern. I'm combining with user's own behavior, his or her purchase history, and now I'm making a recommendation based on that. That's how machine learning would be solving this problem. Make sense?
Makes sense. So, Ashish, I have a question. So, this model that you're showing, which is the intelligent machine, I'll say. So, as data scientists in my organization, do they have to build a model every time, or are there ways out there that I can reuse some models? I hear about open source models, etc. Can you tell me, do they have to build every time from scratch? And the second question I have is, if I'm a consumer, do I need to know about the data, how the model was trained? Do I need that information, or for me it's as good as just feeding in my information and getting the output?
So I would give you my most common answer, it depends. So it depends. What is your use case? What is your use case? Let's work backward from there. So you want to
Okay.
create a method where you have a product and you want a product review to be returned based on the feedback given by customer. Now this may
Okay.
not be something which has not been done before, or this is
Hmm.
not a complex task like launching a rocket to moon. So probably I could leverage existing models which exist for this, right? So maybe some scientific model exists, some vision model exists, maybe some LLM, which is large language model exists. So common task which I can get done by existing model, I won't break my bank to go and train a model. But
Okay.
now I am going to predict the lunar orbits. I am trying to predict the Mars movement, or I am predicting the weather on the Mars. Probably no model has data around it. So that time I may want to build my own model. So I
Okay.
would need to compare the thing, cost, time, data availability, what my requirements are, and then I would make a decision whether I should go for training and building my own model, or I should be leveraging the off the shelf products which are there. Like simple example, we buy shoes, right? Now
Right.
you may buy shoes number 8 or 9 or 10, but maybe you need 8.5. But if a company is not making 8.5, maybe you have that much money and you need that comfort that you could go to company and say, hey, I am paying you this much money, I need 8.5 in this style, please get it for me. If you're paying money, if you can wait, if you can leverage the connection, why not? Otherwise you would probably use what is available as long as it can be serving your purpose, and it may not fit 100%. Even if it is aligned 60-70%, okay, let me now train the model on my own data so it can give me actual recommendation or actual result which I'm looking for. Does it make
Okay.
sense?
Makes sense. And I hear that you can also customize models. I know we'll be
Exactly.
talking about it later. So I don't always have to build from scratch, right? So I
No,
can
probably
augment it
not.
to do more specific tasks. Okay.
Yeah, and it's very costly to train model. It looks very simple word that
Hmm.
I'm training a model, but it could be
Right.
very costly when you're talking about large models.
Makes sense.
Now, I want to talk a little bit more on the model so that everyone is on the same page. What is model behind the scene? So model is a trained algorithm which is used to identify pattern in your data and does not require explicit manual set rules. That is a model. Let me give an simple example, and we'll do a simple activity and we will probably able to get information from there. Now, give me a minute. I'll try to get my pen here so that I can write few things here. Give me a minute. And people attending, please keep your questions coming. You are in very capable hand and you should be able to get a lot of information and questions answered as we are moving forward. So please ask question as much as you can. Now, give me a minute. Probably I have to write down things here. Okay. Let's talk about a very simple topic here. Now, I am drawing something here and that is a triangle. Now, can you predict what would be the next shape coming after this? Probably not, because you do
Probably
not
not.
have context, right? So I
Hmm.
now draw a square here. Now I draw a circle here. Still you can't predict it, what is going to come next. But right. But let me now give you a pattern. Once I have drawn these three things, I go ahead and further draw one more triangle. As soon as you see
Right.
this, now you can see, oh, there is a pattern. So he has drawn a triangle. What should be next coming? Probably it should be a square
Yes. Square.
coming up here, right? And then once the square is there, what should be coming up? What I should be having? I should be having a circle here. So basically what we now do, we have trained a model to understand the pattern, and based on that pattern it is predicting what is coming next. That on a very high level, what a machine is doing, it is trying to understand the pattern, and based on those pattern it is able to predict what is coming next. That's what we are calling generative AI. But now machine learning is not about just creating the pattern. It could be something else. Now let's say I throw a curve ball and I draw one more circle here, and then I go back to my triangle, I go back to my square, and I go back and create my circle here. Now, if a machine is looking at, machine now can say, hey, looks like there is an anomaly here. There is something which is not as expected, and that's what machines are good at picking up. Consider these are all credit card transactions. All transactions are finding similar type of thing. They are following a pattern. There is a buyer. Wherever the country of the buyer is, that is where the product is being shipped. That is where the bank is operating. That is the website they have used. And now I am getting a credit card transaction which says I bought $10,000 of product from US, but I'm shipping it to China, and I have bought it from a Thailand website. That is not a pattern. That could be a fraudulent transaction. So that's what is we are trying to understand from machines. So first thing, we are able to identify the pattern, and if in the pattern if there is anomaly, I am able to identify that through machines. So this is on a high level what machines are trying to do to understand, and that's what a model is actually doing on the sense, right? So that is the idea of model. Let me give you a little bit more information so that you all are on the same page.
So
So
Ashish,
model
I
is a
have one
program. Go ahead,
question. I have a
please,
question
please.
now that you showed us an example of a type of data. Now, this training data, what kind of training data can I use? Like in my organization, we have audio, we have video, we have different types. So, what sort of training data can an algorithm take or a model can be built on? Can you give me some examples that I can
Yeah.
use?
So see, there are two types of thing which we can highly bifurcate it. We call is a single model. I am talking about here MODAL, single model inputs. And then there could be a multi-model input. Multi-model input means the software is smart enough to understand video, it is smart enough to understand text, it is smart enough to understand picture. So that would be a multi-model input we can provide, and it could be also a single type of model. Like I am building a search engine and I just process text, so I need to only have process information of text, nothing more is required. But now Google can get an image also, and based on that image it can also go ahead and then predict what this image is and all the information. That all is going to be a multi-model type of model which I am utilizing. Does it make sense?
Yeah, makes sense.
Good. So model is a program, and what model is doing behind the scene, model is applying algorithm which are not manually set rules, and by that it is able to give the best possible outcome, and relevant input are making the task possible, and then we get the output on that. I will give you analogy at the end, so you should be able to relate all these things into a real life scenario that how actually it works. But model is the brain behind everything, and what is happening within a model, as you said a word algorithm, that is where algorithms are coming into picture. So algorithm is a procedure. Often you put it into a programming language or a pseudocode that is applied to data set to achieve the function or purpose of it. So whatever brain is thinking about, you got a data, you see a fire, that is the input you got. Your brain processes it, oh, there is a fire, I have to extinguish it, can be harmful, I do not need to go near to that. Is what you are performing, and that is algorithm built into your mind. That's how you are trying to identify that. So AI models, algorithm, they recognize pattern and trends in the data, as I gave example of triangle and square and thing. This could look like this, which can have feature, which can have weight. So this is going to be more on the mathematical side. Behind the scene algorithm is basically a mathematical formula, and obviously for different type of input we may need different type of algorithm. Some algorithm may be good for text processing, another could be for video, another could be for scientific data, another could be for prediction, another could be for anomaly detection. So we need different type of models if we need it. So that is different type of models and algorithm which we can leverage. So we have multiple algorithm maybe in a model, they work together, and then we are getting output what we are looking for. So that's how all these things work together.
Makes sense. So Ashish, like we are talking about training. So in order to train these models, of course, these are very intelligent models. You need lots of data. Do we need some specialized software and hardware for that as well, or can we use the regular ones that we use for any other workloads?
See, regular one can be used, but it would not be that efficient as you are looking for, right? So if I'm having a normal phone, I can still make a call from that. But if I have a smartphone, I can make a call. Maybe I can record it. Maybe while I'm on the call, I can start my video also. So you get the point. So yes, the
Right.
basic thing can still happen. If it is a Python code, it is a C++ code, it is a Java code, any machine can interpret it. At the end, it is all the byte code which gets converted into. But if it is a smartphone, it is able to understand different voice, photo, maybe do the checking of the right person or doing a true caller type of thing. So those specialized hardware will make training the model or inputting the data or processing data much efficient, and that's why we prefer to have something which is very specifically trained and which can give us the very specific answer for the question we are asking. So having a hardware which is very specific to machine learning obviously would be really helpful, and that's why we have a lot of emphasis on Nvidia as a chipset, or we have Amazon has Inferentia, we have
Yes,
Trinium chipset.
training
So that is where helping us to get the most out of it.
makes sense. Sure.
Now As the interest of time, I will give you an analogy and try to make sure that you understand all the concepts we have discussed so far. So let me talk about that analogy. Very simple analogy, and you would all be able to relate to it. And obviously, if you have more input, I would be happy to improve this analogy also. So probably all of us use coffee, right? Or maybe tea or whatever it is. So I'm taking example of a coffee here. So let's say we have a coffee shop, and now our job is that obviously to serve customer. And now as we are expanding, we need more people to help us out. We started the coffee shop independently. We are able to provide the services, but now we need more people so that we could do more important tasks. So what we do, we are now going to train some barista for us. So we are going to train barista, and barista would be person who would be making the coffee. Obviously nobody knows making the coffee from the initial school days, so they have to be trained. So we have to train them. Now to make a coffee, we need some ingredients, right? A coffee would have a permutation or combination of coffee, milk, sugar, water. Once you combine them into a specific ratio with a specific equation, that is where you can utilize these coffees. So ingredient is what is your data. Whatever you want to make, you need to provide input for that. And for that particular coffee which I want to make, I need ingredients which is for data. Done. Now, just keeping coffee, milk, and sugar and water together will not make a coffee, right? I need to process it. I need to mix them into a specific order or a specific ratio, and that is where we would have a recipe which is coming up. So for espresso, I do not need anything, I just need espresso. But if I am making Americano, I need espresso and I have to add water on that. I need flat white, I need to add steamed milk on the espresso. Somebody is looking for mocha, I need to give steamed milk and chocolate and espresso on top of it. So what you are seeing here is a recipe, and obviously if the ingredients are same and if I am following the same recipe, I would be getting the same output every time. That is where algorithm comes into picture. So algorithm is basically a recipe that how this ingredient has to be created and connected, and that's how we will get the output associated. Right now, you mentioned about hardware. So can I make a coffee without any hardware? Yes, probably I can make it. But if I need, let's say I need whipped cream, or I need to steam the milk, or I need the milk foam for cappuccino, what I would probably need, I would be needing coffee machine which are very specialized. So people were still making coffee before these machines were invented. But these machines are making your life much easier as a barista, because now you can just make foam if the need be. You can just make the milk hot, or maybe you can cold it, or it has ice also. It can grind the coffee beans for you. So that's what is coffee machine specialized hardware is helping you. And same way, when you're machine learning data, that specialized hardware which you are using, that can also be really, really useful for you. So that is specialized hardware. Now you also mentioned training, right? Now
Right.
barista, I may make them aware that hey, this is coffee machine, this is milk, this is recipe. But again, coffee making is kind of art. Not everyone makes the same coffee, right? So
Right.
same thing here. As I train a barista, so somebody who is smart enough, who has done coffee making for a long time, he or she would be helping that barista to learn. And I don't expect that on very single moment or very first interaction, barista would be able to make the best perfect coffee for me. So I would be training them, and then obviously I would be performing some checks in that. I would provide feedback. Hey, you added more milk. Hey, you have to add more water on that. You have to boil it for a little more point. So that all I am going to go for. So that is why I'm providing feedback. So based on the feedback I'm providing to barista, he or she would be improving the coffee, and that would make sure that we are getting the best ingredient given. And then now my model is ready. Now my barista is ready. I could have helped them to now get started, and probably we have asked them to create these type of coffee foam shapes and this type of art. So now barista is ready. So now my model is ready. Now when model
That's a
is
great
ready, what it is
example.
going to do? Go ahead.
Yeah, so that I think that was a great example, and I think the fact that you said there were different ingredients, so the different ingredients are synonymous to features in my data, right? Some
Exactly.
features are more dominant, like in a particular coffee flavor there was more milk, in some other
More milk is
there was
needed.
more, there's foam. Okay, I get that, makes sense. Yeah, please go ahead. I think it's a great
So
example.
this is how you trained a barista. And now let's say you trained a barista that he or she can make all these shapes on the foam, right? So that is good. And now probably if it is a new barista, I don't want him or her to face new customers every day. What I would probably do, hey, you got trained, and I know that Parna is coming to my coffee shop and she always likes a coffee of this type, and barista has already known it because that is the training data fed to them. Now what I would say, okay, go ahead and serve my regular customers. They are not looking for complicated coffees. They know what they need, and you can break that coffee because I have trained you. So I would be serving regular customer through those particular model got trained. So basically I'm using model is using training data. Now
So
I
I
didn't
have a
expect that.
question,
Go
Ashish.
ahead.
Sorry,
Go
I'm
ahead.
just stopping you there. So in this case, it has been trained on these six types of coffees. Okay, right now, if there is a need for a new kind of
Exactly.
what
Yep.
happens then? Is it when we talk about models hallucinating, we hear about that? Does it start making
Hallucination
up?
is little different, so we'll talk about it if the time permit. But before hallucination, there is one more thing. Like you said, hey, you trained me on making a mocha, you
Yeah,
made me make flat white, I could make cappuccino. What if somebody comes and says I need a ginger tea?
right.
Probably you do not know that. Now what happens? So now, based on training data, you can serve your regular customers. But now, if somebody comes to you and says, hey, you have to deliver me a different type of coffee, or I don't need this shape on the coffee foam, please create a different shape for me, maybe give me something else. So that is where model would apply all this brain. Like, give an example. So you learn programming languages, right? Now,
Right.
have you learned every type of programs in your programming language class? Probably not. They made you aware about how the loop works. They made you aware what is a variable, what is a recursion, how you call a function, and now you leverage that knowledge to write every different type of program, whatever you needed. So you acquired the knowledge, and now as you are trained, as you have experimented, you are applying that knowledge to get the most out of the request which has come to you. So somebody comes that, hey, I need to have a coffee which would have 1+1 on it, which would have thank you return, which would have a question mark. Now model is smart enough that how he makes a coffee and how he makes to that particular thing, that is where model is serving my new customer, and that's what we call inferences. So this is a very technical word which we call inferences. So when a model is predicting something which has not been trained upon but based on the data which has been trained on, so that is what we call a model is inferring. Model is performing inference and then giving me the output. So you have somebody you trained 1+1 is 2. That is good, that is a training data, but now you give them a problem to solve 10+10. So they would use the same logic and give you the result of 20. That is where a model is inferring. So when your barista is smart enough that it knows what are common things to do and it can enhance that coffee which he or she is making, that's where we say our model is ready and it is starting the inferences for our customer. That's how we start. Does it
So
make sense?
inference is similar to making a prediction, right?
This is a prediction we are making. Now, in
Okay.
some cases, I may call it prediction, but let's say if it is an image generation, this is not a prediction, right?
Yeah.
So
Yeah.
it is something we went to create. So it is a generative AI is also doing inferences, or maybe when I am performing anomaly detection or credit card fraud detection, that is what I am creating is a inference right on that, right?
Okay, makes sense. And now talking about training, sometimes we explicitly train, sometimes we ask the person to learn on their own, right? So I heard that even in machine learning, there are different ways of training. And I hear there are different types of machine learning also,
There
supervised,
is, there is.
unsupervised. So can you tell
Yeah,
me a
but
little about that?
yeah, I'll quickly show you that, but we have limited time and we have
Hmm.
Prasad and Sharik waiting. So just give me one more minute and we'll wrap it up. But I would be happy to take it into next session so that we can talk about it. So when we talk about machine learning algorithm, we can talk about three things: supervised learning, unsupervised learning, and reinforcement with learning. I'll quickly talk about it. Sorry for that. So when you are learning as a kid, you have a picture given to you. C is for cat, D is for dog. That is how I learn. That is a label associated with the image. So now as soon as I see this is image, this is this particular image, I would say is it a dog or a cat, right? So that is how we learned. Now I may not have seen every type of dog or every type of cat, but I have been trained on a label data. So now if I see different type of dog or different type of cats, I can still make out that this is a dog or this is a cat, right? Why? Because I know that they would have a specific type of feature, they would have a specific fur type, they would have a specific body type, they would have a tail. So that is how I am trying to perform inferences by different data which has been fed. So that is a label data given to me. Sometime I may not have label data, and now this is a good movie which you should be watching, Hachiko, in case you get time. Check this movie, really interesting movie about a dog. So I would recommend, in case you want to spend your Sunday doing something, check that movie Hachiko. Now coming to supervised learning, what we are doing in supervised learning, we label data. Like we have cars photo, we train to the model and say, model, this is how the car looks like. So next time a picture comes to the model would say, okay, it is compared. Now we have comparison of wheel, we have base, we have a color, we have a style, and now I can say it is a car. Is 100% car? Probably yes, probably not. So this is how we are doing a supervised learning. We feed to model, this is how a car looks like, this is how a cat looks like, and based on that, model is supervising the learning. So that was supervised learning. Now I'll not read all these things. Then comes unsupervised learning. Let's say we do not have data, like see this one. So we are feeding to model all these images. there are cars, there is a bus, there is a truck, there is a bicycle. I have not put any tag on that. I know it is a bicycle, but model does not know. So what we do, we put it to model, and now model can start classifying or clustering them. It can say, looks like all these vehicles are of same type. They have more wheels, they have bigger base, they have a bigger side body, and they looks like there is a place to keep something. So let me classify all of them as one category. Second one, it looks like these are all the places where we have a two-wheeler type of thing, so let me cluster it. So I did not tell model what is a car, what is a bike, but it is able to identify similar type of pattern and say, okay, this is going to be your cluster data, and that's how I will create it. So that is called unsupervised learning. And then comes the example, I'll skip it as of now, and then comes your reinforcement learning. So reinforcement learning, like if your dog, you ask your dog to sit, and if it sits, you give it a cookie. But if it doesn't sit, you do not give a cookie. So like a model, what you do, if you say a model makes right decision, you give him a reward point. If it does not, we do not do anything on that, or we give a penalty to that. So model is now, okay, if I do this, I do not get reward or I get punished, so let me not do that. This is how we are reinforcing what is a good behavior and what is a bad behavior, and based on that we perform reinforcement learning. So that is how we perform all these things. So obviously I will stop now. I would share these slides with everyone, so you should be able to get more details on it. So hopefully that has given you a little bit more idea that how we leverage machine learning and what are some of the common fundamental things we have utilized. All
Sure.
right, I'll stop here
Thank
now,
you so
Sana.
much, Ashish. And I hope the team has also learned a lot from you. So we'll catch
So
up
only
again
thing,
next week.
exactly. The only thing is like the time is always short, and we have steal a lot of time from Prasad and Sharik. So over to you, Prasad and Sharik, and people who have attended. Any suggestion if you have, we would be happy to listen to that. And the slides would be made available to you. We would be sharing more information as we move forward. So let me now add Prasad and Sharik. Thank you so much.